All right, so we're going to now go ahead and look at 2.5, question 11. And what we've got on this one is we want to see if this is a function or not. And then we also want to find our domain. Now, how do we determine if something's a function? That's the simple part. If it's a function, it has been solved or can be solved for what variable? Solved for y, right? So has this one been solved for y? Yes. So is this a function? That's the easy part. Yes. Now, when we look at the domain, what can we not have? Well, when we look at these, and we're going to go to graph these, and we're going to be plugging numbers in, what can we not have? We cannot have negatives under the square root, because that would make imaginary numbers, which you'll learn more about those in college algebra. And what else can we not have? Division by 0. Okay? So, do we have a fraction? Yes, we do. Now, what number is going to make it division by 0? Well, what we do for our domain is we set our denominator to 0. So x plus 18 equals 0. Move that 18 over. And now we're left with x equals a negative 18. That is the number that makes that fraction 4 divided by 0. And we cannot have that because a number divided by 0 is undefined. So what would our domain then look like? Well, our domain is going to be all possible values of x except for what? Negative 18. So how do we write that? We write that as negative infinity to negative 18, all with parentheses. Then we use a u for union. Negative 18 to positive infinity there. And what is that saying? That is saying every number can be plugged in for x except for what? Negative 18. Because negative 18 would give you division by what? 0, and we cannot have that. Do we need to look at any more of these out of the 10 through 15? Let's just go ahead and add one more just to make sure. We'll just do 15. Just to make sure we see the difference between 11 and 15. So when we look at this question, we want to determine first if it's a function. That's the easy part. Has it been solved for y? Yes, it has. So it is a function. Now the domain on this one is a little bit different. Well, what's different about this one versus the last one? Well, the last one, when we look at the denominator, there was an x in the denominator, right? So we had to figure out what number won't work. In this one, is there an x in the denominator, in the bottom half of this fraction? No. So is there any number that's going to give me division by 0? No. Are there any square roots to worry about? No. So what would your domain on this one be? Negative to positive infinity, right? Because there's no x down below. If there's an x in that denominator, you have to figure out what number makes it go undefined. But in this case, there's no number below, no variable x below, so we don't have to worry about that. So do we see now the difference between 11 and 15? Okay, 11 had an x plus 18 below, so we had to see what number didn't work and take it out. On 15, there's no x below, so nothing to worry about with division by 0. 2.6, we're going to look at question 1 first. Now, what we're doing in 2.6 is we're working with functions. And this first question, we have to work with the fractions. So we've got our f of x, which is a minus 5x squared plus 6x plus 5. So that's our original function. And we want to find f of a fourth. So what do? We plug in that 1/4. Is everyone okay with that so far? So we plugged in that 1/4. Now where students struggle is working with these fractions. Order of operations, what do we do first? Well, exponents go first. So we've got this 1/4 and we've got to square it. How do we square a fraction? We multiply it by itself. And when we do that, we get 1/16. Now we can't clear the fractions because we have nothing on the left-hand side to really work with. So we've got to deal with these fractions and keep them. We're now going to go ahead and multiply through. So we've got minus 5/16 plus 6/4 plus 5. Now you could reduce down that 6/4. You could reduce that down to 3/2. But it's not going to matter because we still have to work with these fractions. So it doesn't matter what we do with them, if we reduce them or not. Normally it's just easier to work with them the way that they are. So we need to get these together. We need a common denominator, and that's going to be a 16. So we're going to have to multiply this by 4/4. And that 5 needs a 16/16. That's going to make everything have that same denominator. So now we simply multiply through. So we have a minus 5/16. And we've got 6 times 4, that's a 24/16. And then we've got 5 times 60, which I believe is an 80/16. Now, they all have the same denominator, so they can simply be added together. So you have minus 5 plus 24 plus 80. Putting them all together, we get 99/16. And that's not going to reduce down anymore because 99 is 9 and 11, which is 3 and 3 after that. 16 does not have a 3 in it. So that's as far as we can go. So f of 1/4 in this case is 99/16. Is everyone okay with how I did that? So what did I do? I took my fractions and I squared first because order of operations, that's my first step. Once I squared it, then I rewrote them, multiplied, got a common denominator of 16, added them together, and that gave me my final answer. Question 6. Question 6 is an application. And we're going to be plugging a value in to question 6. So question 6 is talking about the sales of a particular brand of appliance. Okay? And so what happens is the sales are going to increase over time. So we have this function. It's S of x equals 120x plus 4,800. Now, what is S of x? Well, S of x is the sales. And what is x? X is the year. Now, we're going to use what's called key data. it makes it easier than plugging in huge values of x. We key the data to a starting point. So we say that x equals 0 goes along with 1982. So then following this pattern, x equals 1 would go to 1983. X equals 2 would then be 1984. Now what we want is we want 1993. So what value of x would go with 1993? And how do we figure that out? Okay, if we follow our pattern, at x equals 0, that's 1982, right? X equals 1, 83, 2, 84, and so on. If we're at 1982, how much do we have to add to get 83? 1. If we're at 1982, how much do we have to add to it to make 84? 2. So if we want 1993, what are we going to do? Well, we're just going to subtract them. So we have 1993 minus 1982, and that gives you a difference of what? That gives you a difference of 11. So we're looking at 1993, so we're going to have to use x equals 11. Does everyone see that pattern there? Because what are we doing every time? Adding 1, right? Changes the year, it goes up. So 83, we would have 1. 84 would be 2. 85 would be 3. 86 would be 4, and so on. We want 1993. So that means we just subtract them. So 1993 minus 1982, that gives you a difference of 11. Okay, so that's the number we're going to be plugging in. So now we need to find S of 11. So we just simply plug in our value here. And how many appliances are we going to sell approximately in 1993? Well, if we plug that value in, we've got 120 times 11 plus that 4,800. And that gives you 6,120 appliances. That's going to be your answer there. If you take a statistics course, a lot of models work off of this. This is called key data. And why we key the data is it's just easier to work with. It's easier to plug in 11 than it is to plug in 1993. The numbers are smaller and easier to work with. So that's why we key that data. A lot of modeling, especially in statistics, uses key data because you have to have a specific range that you're working with, range of values. So question 8 is the last one out of 2.6. So question 8, we've got a function. And we're going to plug in f of k minus 1. Next week, we're going to be looking at polynomials, and we're going to be multiplying these polynomials out. And we're going to be factoring and dividing them as well. This is kind of a prelude to that. So what we're going to do is we're going to replace that x with a k minus 1. So everywhere we see an x, we replace it with a k minus 1. This now introduces a new concept that we're going to be using a lot in the next chapter. In the next chapter, we're going to be foiling in almost every single question. So for this one, we're going to work with this k minus 1 quantity squared. And we're going to break that down as k minus 1, k minus 1. Just like we did earlier with that first question, where we had to write out the fraction twice and multiply. Same concept here. Now, how do we work this out? Well, we have to FOIL it. So what we do is we take the first times the first. So k times k is k squared. Then we do the outside times the outside. So that's k times a negative 1, and that makes it a minus k. Then we do the inside times the inside, and that makes it a minus k. And then finally, watch your signs. We do the last times the last, and negative times negative 1 makes it a positive 1. In many cases, the middles can be combined together, which they can in this case. And so that's going to make it k squared minus 2k plus 1. And so we'll rewrite that. And now that we have it FOILed, so we did exponents first, and that required us to FOIL. Now we can finish it by simply distributing that 4 through and also that negative 4 through. And I always like to, again, circle the negative, so we remember to change our signs when we distribute through. And that now leaves me with 4k squared minus 8k plus 4 minus 4k, negative and negative makes it a positive 4, and then a plus 6. When we write polynomials, we always write our highest power first. That's just the general way that we write them. So what's our highest power? K squared. So that 4k squared is written first, so that's gone. Then we look at our k's. So what do we have? We have minus 8 and minus 4. That makes it a minus 12k. Gone and gone. And then what do we have left over? Well, we've got 4 plus 4 more, that's 8. And 8 plus that 6 makes it then a 14. So that tells us then that f of k minus 1 is that polynomial. And we're going to be foiling a lot next week when we start multiplying and factoring and dividing these polynomials. Now we'll move on, and we're going to look at these questions off of the practice exam that we asked about. And we'll start with question 7. Okay, so question 7. What we have on question 7 is I give you a point, and I want a line that goes through that point that is vertical. Now, when we talk about vertical lines, what is that? Is that an X line or a Y line? Well, if we forget, we can always do it graphically. So we want a vertical line. So if we draw a vertical line, what axis does that vertical line cross? That vertical line crosses the x-axis. And since it crosses the x-axis, it's going to be an X line. If you forget which is which, draw a picture. Now, what about a horizontal line? What would that be? That would cross the y-axis, right? And that would make it a y line. So this one's a vertical line. It crosses the x-axis, so it's an x line. Now we go to our ordered pair. We want the x value. And what's the x value of our ordered pair? Well, our x value of this ordered pair is then going to be what? 2. And that's all that I want, is simply x equals 2. That's it. What about question 6? While you write this one down, let's talk about question 6. Okay, question 6, we want a horizontal line. So horizontal lines cross what axis? Horizontal lines would cross the y-axis. So that means we would be looking for what? A y line. And so on question 6, what's the y component of that ordered pair? It's simply y equals what? 1. So that's it. So question 7 is x equals 2. Question 6 would be the opposite, and it would be y equals 1. And I don't want you to miss that question. If you forget which way it is, draw a picture. See which axis it crosses. That's going to be which one it is. If it's a diagonal line, that tells you it's got both an x and a y part with it. Question 8. Question 8, we've got the point minus 3, minus 8. And we want it to be perpendicular to y equals 1/3 x plus 18. This is a commonly missed question just because of the algebra and the steps that are involved. So we want to eventually use the point-slope formula. So that means we need a slope. Now the slope of this line right here is 1/3. But I am not going to use 1/3, am I? Because what do we want? We want the perpendicular slope. So that means we want the opposite reciprocal. So what are we going to use for our slope then? Yep, to use for this slope, we're going to use minus 3 because I flipped it over and I changed my sign. Okay, took the opposite. Now what do we have? Okay, now remember, you can use those flow charts if you need to. What are we going to now do? Well, what do we have now? We now have a slope. So we're going to use m equals a negative 3. And we've got that point, minus 3, minus 8. So point slope formula is what's next. And that is y minus y1 equals m times x minus x1. So there's x1 and there's y1. So what did we do? We found our slope. Okay, we've got our slope and our point. Now we can use our point slope formula. So follow the directions, just like a recipe. So we'll go ahead now and plug our values in. So we've got, watch out for double negatives, y minus a minus 8 equals minus 3 times x minus a minus 3 here, right? And again, be very, very careful with those double negatives because those double negatives are going to make it positive here and over here as well. Distribute through, and then we have to write our answer in both slope-intercept and standard form. So clearing out our double negatives, that's y plus 8 equals Distributing through that -3, be careful with your signs. That gives you a minus 3x. Distributing through minus 3 times a positive 3, that gives you a minus 27. Oh, wait, no, sorry about that, not 27. What am I thinking there? No. Okay, so that gives you that minus 9 there. Doesn't matter which form we go first, but let's go ahead and get this in slope-intercept form. If I want to get this in slope-intercept form, what do? Simply subtract off that 8. And that gives you y equals now a minus 3x minus 17. And that is your answer in slope-intercept form. Now we also want to get this in what? We also need to make sure that we get this in standard form. So we have it in slope-intercept. How do we get this in standard form? Well, to get it in standard form, we move that 3x over. And now in standard form, we've got 3x plus y equals a negative 17. So we have it in slope-intercept and also in standard form. The key there was the perpendicular part, meaning we had to take our fraction, flip it over, and change the sign. Question 10 is very similar to question 8. But we have to do a little bit more work on question 10. So for question 10, we've got this point, 2, 2. And we want it to be parallel to this line equation. 5x plus 6y equals a negative 32. Now, we need to use point slope. So that means we need to come up with the slope somehow. We have an equation, and how do we get that slope? We solve it for what? What, right? Okay, are we going to have to change the slope at all? No, why not? Parallel. So go ahead and move that 5x over. And that leaves you then with 6y equals a minus 5x minus 32. Divide by your 6 and reduce this down as much as you can here. So that's going to reduce down to a minus 5/6 x. And then we've got 32 and 6 both have a 2 in them. Okay, so that's going to be then a minus 16 over 3. What is my slope? In this case, my slope is going to be a minus 5/6. And this is the slope that we're going to use. So that is the slope that we're going to be using. Now we're going to proceed and use the point slope formula. So we've got our point 2, 2, and we've got our slope of a minus 5/6. So now we're going to use point slope, which is y minus y1 equals m times x minus x1. We label our ordered pair, x1 and y1, and we plug our values in. This one is a little bit more complicated because of the fraction. So we plug our 2's in, and then we'll distribute that negative 5/6 through. This one will probably be easier if we get it in standard form first. We don't have to reduce the fractions because we're going to have to get rid of them. So we can distribute this through, and that makes it 5/6 x plus 10/6. And you could reduce that down to 5/3, but you really don't need to, because it's going to be gone in just a moment. And let's get it in standard form first. So clear out your fractions. Multiply everything by that 6 there. And that's where students make a mistake, because they might forget one of the pieces. So make sure everything gets multiplied by that 6. So that's then 6y minus 12 equals 6's cancel, a minus 5x, 6's cancel, positive 10. I'm going to go ahead and get it in standard form first, because I think that might be easier. So we'll simply add that 5x over and add that 12 over as well. Now we've got 5x plus 6y equals 22. And there is your answer in standard form. Now we also need to get this in both standard and slope intercepts. We've got it in standard form. Let's go ahead and get this now in slope intercept. So what would we do? Move that 5x back over. And that leaves you then with 6y equals now a minus 5x plus 22. We'll divide by that 6, and we need to reduce it down now. So that reduces down to now be minus 5/6 x, and 22 over 6. Make sure you reduce that down. That's going to reduce down to be 11 over 3. So there's your answer in both standard and slope intercept form. Where students make a mistake at is in the signs, or in a mistake when you multiply. That's the most commonly made mistake. Students, generally speaking, know the steps, but they get bogged down in just some of the simple calculations, the arithmetic. So make sure you're very, very careful. Watch for double negatives, and watch how you distribute. They take a little bit of time to work through, but it's all just simple algebra. Okay, we've got a few more to look at. Question 14. I picked 14 just to review inequalities, because I want to make sure that we get these right. These are the easier questions now. The two hardest questions are the ones we just did, are that 6 and that 10. These are much easier. So question 14, we need to graph this inequality. Well, what do we know? We know that greater than or less than, those get dotted lines. Greater than or equal to, less than or equal to, those are going to have a solid line. So what are we going to have in this case? Well, in this case, we're going to have a dotted line, aren't we? So make sure you know that. These are worth 5 points apiece. If you used a solid line, I'd probably take a point off. So make sure you use that dotted line. Now, we're going to go ahead and move that 2x over so we can get it in slope-intercept form. And now we've got 5y is greater than a minus 2x minus 5. Divide by your 5. And that gives you now y is greater than a minus 2/5 x minus 1. Okay, so now we can graph it. So what is that minus 2/5? That is your slope. And what is that negative 1? That is your y-intercept, which is now the point 0, negative 1. So we've got everything that we need here. So we're going to go back and we're going to plot that point 0, negative 1. So that's right here. my slope is a minus 2/5. So that means we have to go down 2 and to the right 5. We always go to the right. It's either up or down, and always to the right. Never to the left. Always, always to the right here. So we're going to have to go down 2 units and then over 5. 1, 2, 3, 4, 5 units over. So down 2 over 5. There's my second point. We'll plot these together, or sorry, connect these together with the dotted line. We're not done yet. We need to pick a point. It's not on that dotted line. Well, the easiest point to pick is usually 0, 0. And we can use that because it is not on that dotted line. And we check 0, 0 back in the original. You can check it in the simplified form or just back in the original. I generally just have you check it back in the original. That way we don't have to worry about inequality signs. So plugging in that 0, 0, we plug in 0 for x, 0 for y. We get now 0 is greater than a negative 5. And is 0 bigger than negative 5? Why, yes it is. So that means that is true. So that means this half is true. This half is false. Where do we shade? The upper half, because the upper half is what? Upper half is true. Next, we're going to look at question 16. And question 16 is a very, very easy question. But make sure you read the directions for question 16. The directions are on the previous page. What does it say to do for 16? It says, find the x and the y intercepts and graph that equation. So we need to find both the x and the y intercepts if it has them. This goes back to a question we worked with earlier. When we want to graph x equals 7, is that going to be a vertical line or a horizontal line? Make sure we know. Now, if you forget which one it is, just plot that point. If we're at x equals 7, this is my x-axis. So we're going to be using 7 on the x-axis. So 1, 2, 3, 4, 5, 6, 7. Now, we're right there at 7. Well, the only way we can move, we can't go left and right because that would go on your axis. What we can do is we can go up and down. So it's going to be a vertical line like that. Now we need to find our x-intercept and our y-intercept. And we want these as an ordered pair. Well, the x-intercept, where does it cross the x-axis at? The x-intercept crosses the x-axis right here at 7, 0. So my x-intercept is 7, 0. Does it ever cross the y-axis at all? No. So do we have a y-intercept? Nope, we have none. So it has an x-intercept, but no y-intercept. Now there's one that's very similar, I believe, on question 15. Okay, what would 15 look like? 15 would be a horizontal line, right? And it would have a y-intercept, but no x-intercept. And I want to make sure we don't miss this question because this is one of the easier ones. There's not much to it. It's just understanding the concepts of vertical and horizontal lines. Question 17. Same directions again. We want to graph this line, and we need to find our intercepts. So they specifically tell you that they want you to find the intercepts and graph. And what we've got is we've got 2x plus 5y equals 10. Now we want to find our intercepts. So those have our zeros. So the x-intercept would be blank, comma, 0. And our y-intercept would be 0, comma, blank, right? Those are your x and your y-intercepts. They're separate. Do not put them together. So we need to find both of them, plot those points, connect them together to make our graph. So for our x-intercept, we're going to plug in y equals 0. And if I plug in y equals 0, then I get 2x plus 5 times 0 equals 10. That's gone. So 2x equals 10. Divide by your 2. And now we've got x equals 5. So there's one piece. What about the other one? Repeat the process. For the other one, we're going to plug in x equals 0 for your y-intercept. And if I plug in x equals 0, then that's 2 times 0 plus 5y equals 10. Well, we know 2 times 0 again. That's 0 and that's gone. So now we've got 5y equals 10. Divide by your 5. And that leaves me with y equals 2. Now we have everything that we need to graph this line. We've got our 2 points, our x-intercept, and our y-intercept. Plot those, connect them together, and that finishes out this question. So what would our graph look like? Well, we've got that point 5, 0, which is right here. We've got that point 0, 2, which is here. And what do? Connect them together, and we're done. That's it. And those specifically on that question want you to find the intercepts. I want us to think about question 20 because on your exam, I might have flipped it around, or I may have left it the same as far as the slope. So I think on some of the versions I flipped them around, and some of the others I didn't. Okay, question 20. All I want you to talk about is what makes it an undefined slope. So for question 20, the slope is undefined. And if it's an undefined slope, what is that? Well, if it's an undefined slope, that means, when you look at the slope, rise over run, that means it can't run in it. So an undefined slope, well, what is that? That is a vertical line. And that's all I'm looking for, is I'm looking to make sure that you know an undefined slope is a vertical line. Now, what if I would have changed it? What if I would have said the slope is 0? Well, if the slope is 0, what is that one? Horizontal. And this is a very, very easy question. I don't want you to miss this one. It's just definitions. Undefined is a vertical line. Horizontal has a slope of 0. So let's now go ahead and take a short break, and then we'll come back and we'll start our exam. So let's meet back here at how about 9:35, and then we'll spend the rest of our class period working on that exam. And again, if you don't have your homework finished, you can turn it in next week. If you got it done and want me to grade it, I'll go ahead and pick it up. But if you want extra time to go back and double check things, you can turn it in next week.
Will it be late if we turn it in next week?
Do what? No, I don't take off points for late work. Yeah, my philosophy for late work has always been, I would rather you get it done and get it done correctly and understand it than just rush through it. Because you're building on to the next class. So you have to know how to work these out for the next course. So rushing through it doesn't do any good. I'd rather you spend time, get it done and understand it, than just rush through it and not remember it for college algebra.